ratios using right triangles. So below you'll see several right triangles, and some of them have ratios that are the same. I'm going to organize my data in a table. So let's look at triangle A. For triangle A, the base is 8 units. 1, 2, 3, 4, 5, 6, 7, 8. And the height is 6 units. 1, 2, 3, 4, 5, 6. So we'd say the ratio of the base to the height is 8 to 6. We can simplify that by dividing both the base and the height by 2. So in its simplest form, we would say the ratio is 4 to 3. So now I put this into a table, and I wrote the rest of the triangles B through I over here in my left column. So you might want to pause the video here to recreate this table. And then once you start the video again, the next screen will have the triangles for you. So here are your triangles. Again, you might want to pause the video here so that you can fill in your table. And when you're ready, you can resume the video and then check your data with the data I have. So here's my data, and here are some things I noticed. I noticed that triangle A, C, E, and I all have the same ratio of 4 to 3. I also noticed that triangles B, D, F, and G have the same ratios of 3 to 2, and H is the only one that has the ratio of 2 to 1. So if we put these into a table, I would say my ratio group 1 is triangles A, C, E, and I. Ratio group 2, I put the triangles B, D, F, and G, and triangle H was the odd one out. So what do you notice about the lengths or the bases of the sides in each group? Well, let's look at ratio group 1. For triangle A, the base was 8. For C, it was 4. E is 2, and I is 12. So what I noticed is the bases can be simplified to 4. You can divide them all by 4, and for E, I could multiply it by 2 to get 4, or divide it by 4 and get a half. For base B, I noticed that they all could be simplified to 3. Now let's use the Pythagorean Theorem to find the hypotenuse for the triangles in ratio group 1. So in ratio group 1, I have the base as 8 and the height is 6 for triangle A. Remember that to find the hypotenuse, it's the legs added together equals the hypotenuse. Again, we need to square them and then find the square root. So a squared plus b squared equals c squared, where a squared in this case is the base, 8. B squared is the height, which is 6. So 8 squared is 64, 6 squared is 36. The sum of 64 and 36 is 100, and the square root of 100 is 10. So the hypotenuse for triangle A is 10. The hypotenuse for triangle C is 5. For E is 2.5, and for I is 15. Let's use the triangles with whole numbers for the hypotenuse. So we'll look at triangle A, C, and I. Now we can graph these using the coordinates base to height, base being my x, height being my y. There is my table, and you can see the base for triangle A is 8, and the height is 6. For triangle C, the base is 4, and the height is 3. And for triangle I, the base is 12, and the height is 9. What do you see, think, and wonder about the table and the graph? Again, you might want to pause the video here so you have some time to look at this. Now let's investigate a new triangle, and this one we're going to call triangle Z. It has the ratio of the base being 12 and the height being 5. We can rewrite this as a unit ratio. And when we use a unit ratio, it means that we want the first number in our ratio to be 1. In order to do that, we need to divide the first number by itself. Remember, anything divided by itself is 1. So 12 divided by 12 is 1. If I divide the first number by 1, I need to divide the second number by 12 as well. So 12 divided by 12 is 1, and 5 divided by 12 is 0.417, or 417 thousandths. So we'd say the unit ratio of base to height is 1 to 0.417. Now remember that these are equivalent. They mean they equal the same amount. But let's say I want to reverse it. Instead of doing base to height, I want to do height to base. Notice now the height is 5 and the base is 12. I just reversed the order. I can also write it as a unit ratio, but this time I want my first number to be 1 and the first number is 5. So 5 divided by 5 is 1 and 12 divided by 5 is 2.4. So the unit ratio of height to base is 1 to 2.4. Now let's write the base and the height as unit ratios for triangles A, C, and I. The base is 8 to 6, which means we're going to divide 8 by 8, which is 1, and 6 also by 8, which is 0.75. For triangle C, the base is 4 and the height is 3, so we divide the 4 by 4, which is 1, and the 3 divided by 4, which again is 0.75. And lastly, triangle A, 12 to 9, we divide the 12 by 12, which is 1, and the 9 divided by 12 is also 0.75. So again, what do you see, think, and wonder about that? Now we're going to calculate the areas of triangles A, C, and I. Remember, to find the area of a triangle is half the base multiplied by the height. So for triangle A, it's going to be 24 square units. For triangle C, it's going to be 6 square units. And for triangle I, it's 54 square units. So from this table, let's find the ratio of the base to the area. Again, we're going to look at the base and the area. We're not going to include the height for this one. So the base to the area is going to be 8 to 24, 4 to 6, and 12 to 54. Now let's find the unit ratio of base to area. So for triangle A, we're going to divide by 8. And remember, if we divide the 8 by 8, we need to divide the 24 by 8 as well. So the ratio is 1 to 3 for the unit ratio. For triangle C, the unit ratio is 1 to 1.5. And for triangle I, it's 1 to 4.5. Now let's graph these triangles, and we're going to use the coordinates base to area. We're not going to use the unit ratio, we're going to use the first one that we had. Again, we're going to make the base be the x and the area be the y. So for triangle A, it's 8 to 24. For triangle C, 4 to 6. And for triangle I, it is 12 to 54. Now let's look at our previous graph that we did of height to base. What do you notice about the two graphs? So what do you notice about the base to the area as a unit ratio? When I look at triangle A, I notice that it had a unit area twice of triangle C. So this is twice triangle C. I also notice that triangle I has an area 3 times triangle C. How is the difference from the base to the height as a unit ratio? So how is that different? Well, I noticed when I was looking at the base to the height as a unit ratio, they're all the same. I hope you had fun investigating ratios using right triangles, and hopefully that's helped you have a better understanding of how ratios work and especially how to use unit ratios.